Okay. I am going to talk about study of the experimental levitation force capacity of the multi-surface superconductor magnetic system for different HTS-BMG arrangement, and lastly, I mention about the adaptation of this configuration to the hybrid loop system. My outline is motivation after HTS magnetic and hybrid train system, single and multi-surface HTS-BMG interaction. What about multi-surface HTS-BMG arrangement? And experimental and numerical multi-surface HTS-BMG levitation force result carried out by my group. And global warming, lastly I mentioned about the global warming and adaptation of multi-surface arrangement to the hybrid system, and summary. Actually, that's my motivation. There are a lot of study in the world, and you can see in literature, but most of study is based on the single surface HTS-BMG arrangement. But if you use a single surface HTS-BMG arrangement, you have to use lot of permanent magnet, and you use a lot of permanent magnet, your system cost is very high. And last 20 years in the study which were done at different research centers, the desired magnetic force and stiffness value were not assured, and the cost of the system was high because of the use of greater number of permanent magnet. At that situation increased the cost of the system. And another motivation, the number of airline passenger has increased 40 times since 1960, and the fact that airborne carbon dioxide emission will reach 3 times the current level by 2050, showing that the air transport should shift to less energy consumption technology based on the maybe Hyperloop system. Evet. In order to maintain technological sustainability and impede global warming, electrical energy system based on the superconductor material and hybrid transportation technology should be desperate from this point. There is no longer any top. The future mobility will be electrically driven rather than fossil fuel. As you know, there is different type of magnetic field source, like permanent magnet, electromagnet, and superconductor magnet. But these three different type of permanent magnet source or magnet force have a different levitation force behavior, because permanent magnet have a levitation force but unstable levitation force, and the electromagnet have a levitation force behavior stable, but it needs a active supply. And actually, but superconductor magnet have a levitation force behavior, stable levitation force, and if you use a superconductor magnet, you can get the 286 times levitation force value rather than the permanent magnet, because as you know, levitation force ratio secret of the permanent magnetic field density. Actually, magnet based on the levitation component, propulsion component, and lateral guidance component. If you design a magnet system, you can use guidance coil, a levitation coil, or propulsion coil. But I propose using that component, change the superconductor magnet, maybe superconductor coil magnet, because that is very suitable for the energy consumption. Actually, there are generally two types electromagnetic levitation system in the world. One of them electromagnetic levitation, another electrodynamic levitation. Electromagnetic levitation based on the electromagnet bottom side and upper side have a ferromagnetic rail. And electrodynamic levitation based on the electromagnet upper side and bottom side composed of the aluminum rail, and this electromagnetic levitation system based on the repulsive force. And after the velocity, electromagnetic levitation can reach a very high speed. What about Hyperloop system? And it came up last year. Hyperloop system is basically a vehicle that moves at a very high speed, about 2080 km per hour, as magnetically levitated in evacuated tube. And some experimental study is performed in China using the evacuated tube, and commercial Hyperloop system used in the USA and the European Union country. And this study is very new about the Hyperloop system. Single and multi-surface HDS, BMG and interaction. As I mentioned before, there are a lot of study in the world based on the single surface HDS BMG arrangement like this. This arrangement have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 permanent magnet and maybe 1 or 2 superconductor, but this is not realistic for the commercial and technological intervals, because that cost is very high because of the use to a lot of permanent magnet. The another one used the Halbach HDS BMG arrangement. Halbach Halbach BMG have a 5 permanent magnet. That is okay, but let's use a single surface HDS BMG arrangement. And if you use a single surface arrangement, you have a little levitation and guidance force value. And that's a experimental measurement system to determine the levitation force for the single surface HDS BMG arrangement. And if you look the literature, you can see a lot of numerical analytical method used the single surface HDS BMG arrangement levitation force, such as dipole force, current force, and the magnetic stress method and current field force, and a lot of numerical calculation based on the magnetic stress method and current field source. But a lot of study carry out on the single surface HDS BMG arrangement. The last study is about numerical and for the determine levitation force, but single surface HDS BMG arrangement. That study is very successful study because that agree with the experimental and modeling result. That study based on the H formulation, and that study very successful, but that used the single surface HDS BMG arrangement as shown this figure. And the other study performed in China and based on the Halbach arrangement, and that's based on the single surface HDS BMG arrangement. That's the summary of the single surface HDS BMG arrangement. I means if you use 2 permanent magnet, ratio of the HDS permanent magnet ratio smaller than 1, like this, 2 permanent magnet and 1 HTS superconductor. Ratio of the HTS PMG ratio is about 1/2. The another Halbach arrangement has a ratio 2/5 because they use 2 superconductor and 5 permanent magnet. The another 2/7. That's the all single surface HTS PMG arrangement. I mean, why is the multi-surface arrangement is need? Because you remove 1 or 2 permanent magnet per 1000 kilometer magnetic rail, you save about 1.2 billion for a per 1000 kilometer. But you bring a cost approximately $1,800 only to compensate the levitation force removing the 1 permanent magnet. That's a very huge saving cost for the 1000 kilometer magnetic rail. That's my proposal to increase the levitation force, lateral force, and related stiffness value. We use different HTS PMG ratio like 3.2, 1/1, and 6/5. That means I use multi-surface, means 1, 2, 3 surface, maybe 1, 2, 3, 4, 5, 6 surface, then multi-surface. If you use the multi-surface HTS PMG arrangement, you can obtain larger levitation guidance and related stiffness value for the HTS PMG arrangement. That's my group proposal, multi-surface arrangement. Firstly, we designed multi-surface HTS PMG arrangement system to determine levitation force. After that, we fabricate the different cryostat to eligible the different multi-surface HTS PMG arrangement. This means of the single surface actually, because that use the 1 permanent magnet, that's use 3 permanent magnet, but 1 HTS superconductor, but that is a multi-surface because it have a 3 surface between the permanent magnet and HTS superconductor. There's a dynamic measurement system to determine the dynamic parameter of the levitation force system. That's our experimental and numerical multi-surface HTS PMG levitation force result, experimental result. Actually, first one is about analytic result. First time in the literature, we calculate the levitation force for the multi-surface HTS PMG arrangement using the Freudian image method. Firstly, we fabricate multi-surface. We obtain the multi-surface experimental result, and after that, we set energy function depend on the magnetic pole, and after that, we take gradient of the energy function, and we get the levitation force value vertical and lateral direction. And actually, there are a lot of study in the literature, but they use the Freudian image method for the single surface HTS PMG arrangement, but we use the multi-surface arrangement. And result is very similar by the experiment. There's another multi-surface HTS PMG arrangement that's used to 4 permanent magnet, 4 superconductor. The another used to 2 permanent magnet and 3 superconductor. As you see in this figure, horizontal. That's named is horizontal arrangement. It is a vertical arrangement. And as you see in this figure, you can obtain larger levitation force value for the horizontal arrangement, multi-surface arrangement action. And similarly, lateral force is very larger than the vertical arrangement. That is a dynamic measurement result, and similar result is shown in this figure. Actually, I want to say horizontal levitation force value is superior to the vertical levitation value for this multi-surface arrangement. Another arrangement based on the based on the multi-surface HTSPMG arrangement used to 3 permanent magnet and 3 superconductor. Firstly, I calculate the magnetic field distribution using the COMSOL multiphysics package program. That's a numerical method. After that, we take the experimental result, and as you see this figure, if you use the cooling height, zero field cooling height, you can get the larger levitation force value multi-surface arrangement, because MC3PM used to 3 PM and 3 superconductor means of the multi-surface MC is larger levitation force value from the single surface than the single surface. And that figure represents the guidance force, and as you see, if you use the multi-surface arrangement, you will get 3 times larger guidance force than the single surface. Okay. Let's figure based on the experimental result and use the Halbach arrangement. That's how, first we designed a Halbach cryostat, have a maximum 6 superconductor, 1, 2, 3, 4, 5, 6, and 5 permanent magnet, 1, 2, 3, 4, 5. And maybe you can change the number of the superconductor. That's the multi-surface arrangement. Let's look the result, experimental result. And if you use the multi-surface Halbach arrangement, you will get the larger levitation force value than the single surface. That is a single surface, as a multi-surface, and only you use the 6 superconductor on board section. And you will see that this figure, you will get larger guidance force, about 4 times larger single surface. That's the some numerical result based on the variational method, collaboration Spain, and this experimental result, and that's a modeling result, and data is very similar for the experimental and modeling, and maybe first time we used the numerical method used based on the multi-surface arrangement, because a lot of study indicated based on the single surface. Lastly, I want to mention about the global warming, because very summary. In 2013, global carbon dioxide emission from the commercial aviation 710 million ton. In 2020, 2018, it climbed 4% and reached 905 million. And by 2050, commercial aircraft emission could treble. And that figure say us, we changed the conventional transportation system maybe to the maglev system or hybrid system because they the energy efficiency. And if you use the superconductor for the maglev system, you will get the outstanding acceleration and deceleration performance rather than the conventional maglev system. Actually, a hybrid system based on the tube, port and terminal, and hybrid system will get a 1080 km/h very high speed, and maybe air transportation for the hybrid system next future. This is some proposal from my group for the hybrid system. Actually, general hybrid system based on the permanent magnet on the board or electromagnet on the board or outside. We can change the permanent magnet to superconductor magnet or superconductor coil. Because they are very energy efficient. Another proposal is about that we can use the superconductor magnet on the board instead of the active electromagnet. And as a summary, in this study, to improve the magnetic force properties and decrease the cost at the same time, newly maglev system has been designed which have multi-surface HDS-BMG arrangement. That's ratio of the HDS-BMG arrangements larger than 1. Another conclusion, it can be concluded from this study that both loading, lateral guidance capacity and so the stability can be enhanced, and the fabrication cost of the maglev system can be decreased significantly by using the multi-surface HDS-BMG arrangement. The explanation of this experimental observation is supported by the dedicated theoretical modeling through 3D approximation of the system. And lastly, in order to maintain the technological sustainability and impede the global warming, together with the renewable energy system, passive electrical energy system based on the superconducting material and hybrid transportation technology should be discovered. Thank you very much.
Thank you. This looks like a very brilliant idea. It's very interesting. I was wondering if you have tried to, at least in calculation, understand if you can scale up. Is the last part that you showed to the real system? Is it something that requires a big effort to scale up from the lab scale to a real maglev, or like the force will be much higher? Is it? I mean, essentially in the last part you showed that it's feasible. I wanted to understand better. Yes. I mean, to scale up to a real system, the force that you need, is it something you need much more, or is it scalable? Your system is, I think, very brilliant idea. I want to understand if it's scalable.
There's an experimental scale in the laboratory, but right, maybe we will have some issue, real scalable maglev system, but just only we will continue experimental laboratory scale.
Thank you.
Maybe features. Okay.
Sure. Thank you.